All right, so next we're going to talk about permutations. A permutation is a distinct arrangement of some groups of individuals. When we say distinct, the idea behind distinct is that the order matters. So the first position matters, the second position matters, so order matters. So keep that in mind as you're thinking of, is it going to be a permutation or section 48 a combination? Now to do this, we need to know what a factorial is. A factorial is the product of numbers, starting with that number n and going all the way down to 1. So if I want to do n factorial, the symbol for a factorial is an exclamation point. You start with n, and then you subtract 1, and subtract another 1, all the way down to 1. So for instance, if I wanted 5 factorial, I would do 5 times subtract 1, 4 times subtract 1, 3 times subtract 1, 2 times subtract 1, 1. This would be 5 factorial. And again, you would multiply this out, and I believe that it's around 120. I think that's what it is. Okay? All right, very good. So that's factorials. So let's see what we're doing next. Okay, example here. So it says the manager of a youth baseball team has picked 9 players to start an upcoming playoff game. How many different ways are there for the manager to arrange these 9 players to make up the team's batting order? So if you know baseball, you know that a batting lineup, a batting order, has 9 positions. So there's leadoff, second, you have third, fourth is the cleanup spot, fifth, sixth, seventh, eighth, and then ninth, right? So we're going to multiply all the possibilities of these 9 positions. So if you have 9 players in the first spot, you have 9 possible players to choose from. But once you pick that player, now for the second spot, you only have 8. And now that you've picked those 2 spots, now for the third spot, you only have 7. And now those first 3 spots, now you have 6 and 5 and 4 and 3 and 2 and 1. So when you have the same number of people as you do positions, this is simply going to be 9 factorial. Now, you can go through and you can multiply this out, or we can just do 9 factorial in our calculator. And that's what I'll do, 9 factorial. Calculator, 9 exclamation point. There we go. And that's how many different batting orders there are. 362,880 batting orders. And again, this matters, right? Order matters. Think about if order didn't matter. If order didn't matter, if I had 9 players to fill 9 spots, it would just be one way. They'd all get to play. But because the order matters, there's so many more. So keep that in mind. All right. Next objective coming. Now we're going to talk about permutations, but what happens if there's more people than there are spots available?